Okay, now here's oxidizing charcoal fines. So this is just to prove that you can do it in the laboratory. Here we have 3 test tubes with another kind of salt, carbonate salt plus some nitrate salt, where we've added charcoal fines. All right, so it's kind of blackish in color because it's got lots of charcoal powder basically in suspension. And here's different amounts of nitrate we add to it. So we call this oxidizing it because it's not burning it. It's indirectly burning it. It's burning it in the sense that nitrate can lose an oxygen, become nitrite. All right? That oxygen can be used to turn carbon into carbon dioxide. Okay? But it's not directly burning it. It's much more efficient because it's in the salt everywhere. It's a solution. So everywhere where there's nitrate, if you have a charcoal particle, for sure it's going to be reacting with the nitrate. Now it's turned into nitrite. You need to turn this nitrate back, nitrite back into nitrate. You just bubble some air through it. Everywhere there's nitrite, so the air will be very efficient in turning it back. So after 15 minutes, this has become clear. You see this black become clear. No smoke, okay, no ash, 100% efficiency in transferring the heat to the salt because it's done locally. If it's big, you won't have much in the way of surface area. After 30 minutes, it's become like this. After 60 minutes, it becomes like this. So it's just directly proportional to how much nitrate, which shows that you're not burning it, okay? We're adding air at the same rate at all of these things. It's just really this oxidizing with. Now, the unfortunate thing about this is that this oxidizer salt, unlike the previous salt, is highly corrosive. So if you want to use things other than test tubes, you must find some appropriate alloy. And Professor CityU is developing developing a new iron aluminum alloy to make this. That's our next step. Okay. Once we have that in place, then we think it can become self-sufficient. All the energy is what you have in the biomass itself. And the return on energy is roughly this. Depending on how wet the biomass is either 1 in, 10 out, or 2 in and 10 out, 1 in 5. So it's not bad. It's for the nuclear physicists, you can think of it as a breeder reactor with a very high breeding ratio.